everybody, today we're going to be working on Worksheet 3.5, which is just a review of the past few days since I am out. So the first thing we're going to do is graph the following inequalities, and we want to make sure to do double shading. We want to make our feasible region dark. So our first line is going to be vertical because of Hyvix. So I know when I have that x equals, that's a vertical line. So make sure you're on the x-axis. We're over at 4. Since we have the equal to line, this means we do have a solid line. And then this is a greater than. Remember, for vertical lines, greater thans mean we shade to the right, because on the right we have the numbers that are greater than 4. So you can shade all the way to the right. Okay, or if you want to use the arrows method, you could just draw some arrows to the right. Okay, then we're going to go ahead and graph this second line. It's already solved for y. We have another equal to, so this will be a solid line as well. Y-intercept down at -3. We're going to go down 1, right 4. Now, I know we intersected the line here. That's not actually important. Remember, we care about where our shades intersect, not our lines. But, you know, it is nice that it intersects so nicely. Solid line. This is a less than, so that means I'm shading below. So everywhere below. And you can see this region where it's become kind of red. That's my feasible region right there. So if you'd like, you can label it. Or if it's obvious, you don't need to. All right, let's try the next one. Number 2, we also need to look at Hyvix, but this is a y. That means I'm going to have horizontal. Make sure you're up at 6 on the y-axis. This is going to be a dotted line because I don't have that equal to. And it is a less than, so I will be shading below it. Okay, my next line has a y-intercept of 6 as well. I'm going up 2, right 1 because of that +2 slope. Make sure you keep drawing your line the other direction as well, down 2, left 1. And again, this is going to be another dotted line because I have that I don't have that equal to line. This is a greater than symbol. So greater than means I'm shading up. All right. So for example, here's my line. I'm shading up. Up means it's really that left-hand side of that line. Okay. So everywhere to the left of my line, and you can see where it's getting this dark blue region, that kind of triangle. That's where my feasible region is. Okay. So like all in here. All right, number 3, our first one is already in slope-intercept form, so we can graph right away. Go ahead, y-intercept at -1. We're going to go up 2, right 1. And this line will be dotted because I have the less than here. There's no equal to, so make sure you dot it. And it is a less than, so I will be shading down. So again, here's my line. I go down below, and that means we're really like on this whole right side of the line. All right, but our second inequality, we need to solve for y still. So I'm going to start by subtracting my 2x over. I've got a -3y greater than or equal to -2x plus 9. Notice how I didn't combine those. And then I'm going to divide by my -3. Couple things we have to be careful of here. We're dividing by a negative with an inequality, so your symbol does need to flip. -2 divided by -3 is a +2/3. Don't lose your x. 9 divided by -3 is -3. So this is what we're going to be graphing. Make sure you have your equal to. This line is going to be a solid one. So y-intercept at -3, I'm going up 2, right 3. And again, make sure you reverse it as well. Get that whole line on there. And this is a solid. Oops. Okay, that's going to be good enough. It should go through those dots better, but oh well, I hope you'll forgive me. And we are doing a less than, so you're shading below that whole line. So if you notice, it's where this is turning green. That would be our feasible region, everywhere below that line. All right, one more like this, and this is a double HIVEX. We have a horizontal and a vertical. Horizontal, remember, is the Y, so go ahead and find -4. And that one is going to be dotted. Okay, and this is a greater than. Remember, greater than means we shade up. Or above your line. This guy, X is less than or equal to 8. X is a vertical. Make sure you're on the X axis. This is going to be a solid vertical line because of that equal to. And remember, with verticals, we shade a little differently, okay? So greater than, we shade left. Less than, greater than, we shade right. Less than, we shade left. So since this is a less than, I'm struggling here, we're going to shade to the left. And it's where this is becoming red. That would be your feasible region. Okay. All right, so now let's flip to the back. And here you're given a feasible region. It's this guy right here, the darkest part. And we're just going to see if these points are solutions. Remember, if you are a solution, you have to be in the shaded region or on a line of the shaded region, but it has to be a solid line. All right, so -6, -7, that's over here. That is not in the darkest part, so that's just a no. 7, -9, that would be down here, which is in the shaded region, so that would be a yes. 4, -6. All right, be careful. That's actually right here. It is on a dotted line. It's also on a solid line, okay, but it is on a dotted line as well. So that means it works in one, but not in the other. So this is going to be a no as well. Okay. All right. FBLA plans on selling tins of popcorn and tins of peanuts as a fundraiser. FBLA wants to spend at most $1,200 and order at least 350 tins. Each tin of popcorn costs $4 and each tin of peanuts costs $3. Let C represent the number of tins of popcorn and P represent the number of tins of peanuts. Write a system of inequalities. All right, so the first thing we want to do is make sure we find our totals. Take a moment to see if you can figure out which of these are your totals. And we're going to put those right over here. Okay, so it should be a 1,200 and a 350. And be careful, a lot of time we want to put equal signs because that's just what we're used to. But we're dealing with inequalities here. So when it says at most 1,200, remember at most means less than or equal to. And at least 350, at least means greater than or equal to. And then remember, money always has to go together. So this 1,200, which is money, that's where we're going to put our $4 for the peanuts. And, oh, hold on. We have popcorn and peanuts. So 1 second here. Popcorn was C. All right, so 4C plus peanuts was 3P. Okay. And then for the 350, that's just the total number of packages bought. So that's just going to be C plus P. All right, so our last problem today is one of our linear programming problems, which we will continue more with next week. So you work for your mom's company over spring break to earn some spending money. You spend your time working on 2 different tasks, answering phones and working in the mailroom. You are able to work no more than 8 hours that week. The budget of the company allows you to earn $90 or less. You earn $10 for answering phones, and you earn $15 for working in the mailroom. I'm going to go ahead and label those on my axes real quick. So mailroom is $15 and answering phones is $10. X is the number of hours you work answering phones, and y is the number of hours working in the mailroom. So if you notice, we already have our equations written down here. Okay, and now what we're just going to go ahead and do is start answering these questions. Okay, because we've gotten these graphed as well. Could you answer phones for 4 hours and work in the mailroom for 3? So phones for 4, you're going to come over here. Mailroom 3, that's this guy right here. We can see it is in the darkest part, so this is a yes. And we know because 4-3 is in the feasible region. All right, how much money would you make for answering phones for 5 hours and working in the mailroom for 1 hour? All right, so here's how we would do that. We're answering phones for 5 hours, and I'm just going to come up here. Phones, we earn $10 for each of those hours. Okay, so that means I made $50 just answering phones, but I also worked in the mailroom for 1 hour, and in the mailroom, I make $15 an hour. And that means I'm going to make a total of $65. All right, now, our last question, you decide to only work in the mailroom. What is the maximum amount of money you can earn? So this is something we're going to talk a lot more about on Monday, but what you want to do is find mailroom. You want to find the highest point of your feasible region, so that's 6 right here, 0, 6. So that's 6 hours that I worked in the mailroom. And again, the mailroom, I'm making $15 an hour. And 6 times 15 is 90. All right, so then just make sure you answer the question. I work 6 hours and make $90. Okay, so what you want to go ahead and do now is make sure that this is all completed, and then go ahead and put your name on the top, please. All right. If you could also put what period you are, so either 7 or 8, whichever that happens to be, and then you want to give this to the sub, okay? And then you will receive homework points for this. You'll get it back on Monday after I put all your scores in. And then you want to find if you have any missing work that you need to complete, you can do that. Or if you have something to work on for another class, that is fine as well. If you were using your phone to watch this video, you do now need to put your phone away, and you cannot have your phone out until pack-up time. So please be respectful to the sub and get done what you need to get done. And I hope you have a great weekend. Bye. See you Monday.